Hi, pre-calculus students. Welcome to section 4.8, the last section in chapter 4 on trigonometry. Today we're going to be talking about trigonometry and bearings, and we will be converting between trig and bearings. Notice that we always evaluate our trigonometric expressions using angles from the positive x-axis, depending on what quadrant we're in. But notice if you wander out into the real world, there's no XY plane. And so, but what we do have that is real is true north, right? Right? We measure where we are, what angle we are from a north line, right? And that's the way our navigation systems work too. So what we're going to do is be working in 4.8, among other things, with a little navigation. So they're going to be giving us information and bearings. We're probably going to have to use some trig to answer the question using, our angle, our reference angle from the x-axis, and then convert back to bearings. So let's get a handle of bearings. So on number one here, notice, so when you rotate, usually with the bearing, you rotate east of north. Right, so you start at north and you rotate east. And so notice in this picture here, we've rotated 145 degrees east of north. We can call this a bearing in two ways. Notice this is a bearing of south 35 east. Notice if you start south and you go to the east, right, 35 degrees, the 35 is in the middle of south and east, right? So south 35 east is a way to name this bearing. Or when they don't give compass directions, it would just be a bearing of 145 degrees. So when they give you a bearing of 145 degrees, that's always how far you rotated east of north, right? Let's look at this bearing here. This bearing is a bearing of 280 degrees. Again, that would be east of north, or somebody could describe this as a bearing north 80 west, because they started at north and rotated 80 degrees to the west. This bearing here is a bearing of north 45 east, or simply a bearing of 45 degrees, or it is also called directly northeast. So if they say that something is traveling directly northeast, they do mean at a 45 right between north and east. So let's get some more information. So I'm going to pause our video, get some more information on the board. There we go, like magic. Here is problem number 4. So you will have problems where you have a bearing from a location and then going back to that location. That is not the same bearing, right? Because you are going in the opposite direction. So let's say that you're at an airport, right? And we have that on the compass. So a bearing always comes from the center of a compass, right? So let's say your bearing from an airport is 110 degrees. When it says that, of course, that is east of north. So a bearing of 110 degrees, right, would be right here, right? Here's 90 degrees plus 20 more, right? So this is actually a 20-degree angle if we were concerned about our trig, right? That way, I'll make that a little bit bigger. That would be a 20-degree angle, but this is our bearing, right? If you are flying from the airport of a bearing of 110 degrees, right? That is your direction, okay? Now, let's say that you come to a location here. Let's use green. I'm not sure if green will show up. That you are at this location now, right? From the airport, and you want to fly back. You're going to fly back to the airport now, right? So if you're flying back to the airport, if you are right here, right, you are flying back to the airport, but notice a bearing comes from the center of a compass. So here is your direction in green back to the airport. And so what you have to do to get the actual bearing is to keep that flight pattern, keep that direction to the airport, and then make that bearing line coming through there so you can see this is the actual direction you're flying, but your bearing comes from the center of the compass. So notice that you're bearing back to the airport then. If this was 20 degrees, so is this one here. And now your bearing back to the airport is, this is 90, 180, 270 plus 20. And so your bearing back to the airport is 290 degrees. Okay, again, your bearing from the airport, 110 degrees, right? The flight back comes from the center. That is a bearing of 290 degrees. So let's try some examples now. And here are our two examples. So number one, a ship leaves port at noon with a bearing of south 29 west at 20 knots. How far south and west is the ship at 6 p.m.? So let's take a look, right? So we are always traveling from the center of a compass. Here's your port right here. And this is at noon. This is at noon. And it has a bearing of south 29 west. So south and 29 degrees to the west, right? So here's south, 29 west, at 20 knots. 20 knots, it's 20 nautical miles per hour. And they want to know how far south and west is the ship at 6 p.m. So notice it also that this ship, right, it was here, and it is at this time, 6 hours later, it is more south and more west. Now there's a couple ways to draw this triangle. I could make a triangle here. I could have made this a little straighter. Just gonna make it a little straighter, right? I could draw a triangle here, and this would be right west and south here, right? I also could have drawn the triangle here and then reworked the angle, right? So my angle of 29 is right here. Okay, now what I need then is I need this side south and this side west here, right? So notice what I actually need is I do know how far, I do know how long this hypotenuse is of my triangle, because I do know that the ship has been traveling from noon to 6 p.m. So that's 6 hours at 20 nautical miles per hour. So this length is 120 nautical miles here. There we go. So now 120 nautical miles, I can use trig to find the south and the west. So let's take a look here. So my length of south here would be cosine of 29 degrees would be south over 120, right? So I can just multiply both sides by 120 to get south. Make sure you're in degree mode on your calculator, right? Let's go ahead and get that. 120 cosine of 29, and I am 104.95 nautical miles south. Okay, now to get west, how far west, right? That would be sine, right? Because that would be opposite over hypotenuse. So that would be sine of 29 degrees equals west over 120. Notice I can multiply both sides by 120, just like I did to get west. But this time, I am using sine. So 120 sine of 29. And that ship is now 58.18 nautical miles west. There we go. Number two, A plane is 90 miles south and 110 miles east of an airport. Okay, so our airport, let's see how this red shows up. The airport is at the, oh, that shows up pretty good. The airport is at the center of the compass, of course. The plane is 90 miles south and 110 east, right? So 90 south, 110 east. The plane is right here of an airport. What is its bearing to the airport? So let's go ahead and draw that bearing, right? So the plane is going back to the airport. This is the direction it's taking, right? I have to keep that bearing going. No, this is the actual bearing from north, is to continue that path, right? So I think what would help is if we got this angle theta here, right? That would help us find the bearing back. So let's take a look. I have from theta, I have an opposite and an adjacent side. So I'm going to do inverse tangent of 110 over 90, right? And we're going to get that angle and we're going to use it to help us with this bearing here. So that is inverse tangent of 110 divided by 90. That is a 50.7 is this angle measure here, right? Which means that this angle measure here, right, by vertical angles is also 50.7, right? So this angle and this, because they're vertical, is 50.7. So the bearing from north is 50.7 degrees less than 360. So my bearing is 360 minus 50.7, right? So 360 minus 50.7, that is a bearing of 309.3 degrees. There we go. So thanks for hanging out with me today in the classroom and hope you enjoyed this video.